Hi everyone, this is Mrs. T from Mrs. T's Chem Talk AP Chemistry. This is going to be a video for the introduction to the VSEPR chart. If you are taking AP Chemistry next year at our school, you are going to need to watch this as part of your summer assignment in order to know what's going on with that chart. For those of you who don't know me, my name is Mrs. T and I teach chemistry at Calhoun High School. VSEPR is the acronym for Valence Shell Electron Pair Repulsion Theory. VSEPR is a model used to predict the shape of molecules based on minimizing the repulsion of a molecule's valence electrons around a central atom. Basically, because all the electrons are negative, they're going to push away from each other, and the shape that the molecule is going to take will be the one that allows for the electrons to repel each other in sort of the least way. So this is the part of the chart. For those of you who are taking AP Chemistry next year, this is the part of the chart that we assign to you. And the way that the chart is organized, we have valence electron pairs, bonding electron pairs, non-bonding electron pairs, VSEPR formula, 3D structure and approximate bond angle, and then also an example. So I just want to clarify that when we talk about bonding electron pairs, I usually change this to bonded atoms around the central atom because we don't count the second bond of a double bond and we don't count the third bond of a triple bond when we're talking about these bonded electron pairs. So the way that I do it is bonded atoms and non-bonding electron pairs, which remember are called lone pairs. So for the first one on the chart here, when we're talking about valence electron pairs of 2, bonding pairs of 2, and non-bonding pairs of 0, what that means is that there are 2 bonded atoms around the central atom and there are no lone pairs on the central atom. So we are always focusing on the central atom. So this has 1, 2 atoms bonded, and 0 lone pairs. So 2, atoms bonded, and 0 lone pairs. That means that this molecule will be linear. And for it to be linear, that means that if we start at the central atom, the angle between that atom and the other atoms will be 180 degrees. This is in a straight line. So if you have 2 atoms bonded and 0 lone pairs on the central atom, it'll be called linear with a bond angle of 180 degrees. If instead we have 3 atoms bonded and no lone pairs, we're going to call this trigonal planar with a bond angle of 120 degrees. The way that those electron pairs can get the furthest away from each other is going to be in this trigonal planar arrangement. So look, we have 1, 2, 3 atoms bonded and no lone pairs on this central atom. So 3 atoms bonded, no lone pairs, trigonal planar. These are flat, and the bond angle between each of the atoms is 120 degrees. But if we look under 3 valence pairs, we also have a possibility of having 2 bonded atoms and 1 lone pair, which the number of pairs of electrons still adds up to 3. So this big number here is our steric number. The electrons are still trigonal planar. But the molecule now, instead of being trigonal planar, the molecule is now called bent. So 2 bonded atoms, 1 lone pair on the central atom means that the molecular geometry is bent and it is a bond angle of less than 120 degrees. And as we see for ozone, the actual bond angle observed is actually 116 degrees. So number of bonded atoms plus lone pairs gives you the steric number. And then two of those were bonded atoms, one was a lone pair. So now the shape is called bent with a bond angle of less than 120. And luckily for everybody, this set should be something that you're familiar with in terms of the names of the shapes and the dot diagrams. When we're talking about 4 bonded atoms and no lone pairs on the central atom, that would be 4, 0, we're going to call this shape tetrahedral, and these bond angles are equal bond angles, and these bond angles are 109.5 degrees. When one of these bonded atoms is a lone pair instead, that's going to change the name of the shape and change the molecular geometry. If we go to 3 bonded atoms and 1 lone pair, 3 bonded atoms, 1 lone pair, my steric number is still 4, but now this shape is called trigonal pyramidal. And these bond angles between here and the one in the back that you can't see are now going to be less than 109.5 because the lone pair up here, what I like to call my lone pair hat, actually takes up more space and pushes the atoms down closer together. But again, count the atoms bonded on the central atom, add the lone pairs, that gives you the main number, and then because one of them is a lone pair, it's the second one here, which is trigonal pyramidal. And then the final one that we need to know here should also look very familiar. Water has 2 bonded atoms, 2 lone pairs. 2 plus 2 gives us our steric number of 4. 2, 2 is bent, right? This is bent like an elbow. And this bond angle, again, is less than 109.5 because these lone pairs take up more space than the bonded pairs, and they push down on those bonded atoms a little bit, those bonded electron pairs a little bit. So in summary here, we're going to take the number of bonded atoms on a central atom plus lone pairs to get what's called the steric number. That steric number, if it's 2, it's found in here. If it's 3, it's one of these. If it's 4, it's one of these. If they're all bonded, it's the top one. If there's 1 lone pair, it's the second one. If there's 2 lone pairs, it's going to be the third one. Every lone pair drops you down 1 on the list here. Once you know your number of bonded atoms plus your number of lone pairs, you can associate that with the name of the shape and the approximate bond angle. So in order to make sure that you learn these, what I would suggest is put bonded electron pairs or bonded atoms and non-bonding electron pairs or lone pairs on the front of an index card and put the 3D structure and approximate bond angle on the back of the index card. So if you can do bonded atoms plus lone pairs on the front and know on the back what the name is and the bond angle for this section of the chart, you're going to be in a good place to know what you need to know when you come back to school in September. So that's the end of our VSEPR introduction video. Hopefully this was helpful. Since in September you will either have myself or Mr. Ludwig, you can feel free to email either of us over the summer or just ask us in September your questions that you have.